In this part of the tutorial, we're going to discuss how to set up global parameters using arguments in order to specify arguments within blocks. Typically, these are used when certain arguments within blocks need to be synchronized, or as we shall show later, when you use hierarchical blocks, where the parameters for hierarchical blocks are set up using arguments. We will continue from tutorial number 2. So we'll go to the file, open up, we save that from last time. Let's review what the topology looks like. Again, we're generating digital data, encoding it, increasing the sampling rate, doing pulse shaping, and of course looking at the spectrum and time domain and also the eye diagram. The pulse shaping filters are Nyquist pulse shaping filters, and they have a parameter which determines the roll-off factor. When the roll-off factor is a half, that corresponds to 100% excess bandwidth. In fact, the widest bandwidth for that particular pulse shaping filter. Let's go ahead and decrease that to 0.1, which means that we're going to have a bandwidth efficient pulse shaping. So if we change that for the square root Nyquist on the transmit side, we have to change it also for the receive side. So let's go over here and change the parameter, also set that to 0.1. And let's go ahead and run this simulation. Now of course you get an eye diagram and a spectrum. The spectrum is actually narrower than the case where we had a roll-off factor of a half. Also the eye diagram, you'll notice, is quite different. We'll discuss the differences between these eye diagrams, between the different roll-off factors in a minute. One of the things we wanted to illustrate was the fact that these two blocks have a parameter that has to be the same between the two blocks for them to make any sense. That is, the parameter between the transmitter and the receiver have to be the same. One way to guarantee that is a feature in Capsim, which is global arguments. If we go to the toolbar, this particular button represents the arguments. Now, arguments are also used for defining the parameters to hierarchical blocks, and in this case we're going to use them to generate a parameter which is global and is shared between multiple blocks. First, when we select this button, you'll notice that there are no global parameters or hierarchical arguments or parameters specified. Therefore, first thing we need to do is add an argument. So we click on this button. When we click on Add Argument, we get a dialog box, and that dialog box allows us to specify the argument type, which in our case is going to be a floating point number. A prompt for the argument, which in our case is going to be roll-off factor. And a value, and we're going to start out with 100% excess bandwidth, which was a half. Now the argument has been created. As you can see, we have an argument which starts from argument number 0. In fact, the 0 here represents that this is argument number 0, and we refer to arguments by their argument number. Now if we go back to our transmit square root Nyquist pulse shaping block and we click on change parameter, we want to specify the roll-off factor using the argument. So we type in arg0. So basically arg space 0 referring to argument 0. And if I hit OK, that basically specifies a parameter for this block. Let's go ahead and check that. So if I say change parameter again, you'll notice that it says arg0, and over here you'll see that the value is a half, which is exactly what it is in the global argument. Okay, let's go and change the parameter for the receive square root Nyquist filter and specify arg space 0. Let's check that again. You'll notice that the value is a half now. At this point, it's not a bad idea to save the topology. We'll go ahead and save this as tutorial number 3. Because we're going to actually run the simulation. So let's go ahead and run, and now you'll notice that the eye diagram corresponds to 100% roll-off factor. You can see the actual time domain also. Let's keep the spectrum and the eye diagram around, and let's change the roll-off factor to 0.1 and run the simulation again. Now we get a different eye diagram and of course a spectrum. You'll notice that the time domain has also changed considerably. Let's get rid of that. We're going to compare the frequency, the spectrum actually, and the spectrum changes quite a bit. As you notice, for the case where we have a 0.1 roll-off factor, the spectrum is quite less than the case where we had 0.5 roll-off factor, which was 100% excess bandwidth. So now we basically have a pulse shaping which uses much less bandwidth and is bandwidth efficient compared to the case where we had 100% excess bandwidth. However, there is a trade-off. If you look at the eye diagram here, you'll notice that in the case of 100% roll-off factor, we have a lot of immunity to jitter. If you'll notice, if we have clock jitter, then our sampling would instead of being right out here, we'll have jitter around the sampling rate. And in this case, if we jitter a little bit, the amount of intersymbol interference is very little. But in the case of 0.1 roll-off factor, if we do have jitter around the sampling point, if we move a little bit around here, we'll see that there is a lot of intersymbol interference due to that jitter. So the tolerance to jitter is much less, although we are using less bandwidth. So we have a trade-off. In order to be more immune to clock jitter, we have to, in fact, increase the roll-off factor, have more bandwidth, use more bandwidth, and then we have immunity to jitter in this case. But if we want to use less bandwidth and be more bandwidth efficient, then we have less immunity to clock jitter, and we have to design a better clock recovery system. So this is quite amply demonstrated in this Capsim simulation. Let's go ahead and get rid of all these plots and illustrate the use of global parameters one more time. In this case, we'll go back and change it to 0.25 roll-off factor. And run the simulation again. And you'll notice that the eye diagram is a little bit better than the case where we had for 0.1, and we've of course used more bandwidth. So in this tutorial, we have actually illustrated how to create global arguments and how multiple blocks can share a global argument, and this comes in very handy when you are sharing sampling rates or splitting parameters between transmit and receive, and you need to guarantee that the transmitter and the receiver have the same parameter for their filter specifications or other parameters. This concludes tutorial number 3.